Okay, in this video, we're going to be doing Calc AB Problem Set 123. That's kind of a neat number. The problems in a playlist are in the description below. Let's do it. Evaluate the derivative of arcsine of cosine of 3x. All right, the derivative of arcsine is 1 over 1 minus u squared times the derivative of u. So let's just start with that. 1 over square root of 1 minus u squared, so u is cosine of 3x, so we'll get cosine squared of 3x, times the derivative of cosine of 3x, which is negative 3 sine of 3x. And that's the whole problem, but I mean, if you don't know how to do it, you don't know how to do it. So let's take a look at the next one. Evaluate the integral from 6 to 12 of 1 over 1 plus the quantity x squared over 36. I mean, I think I just put that quantity there because the way I type these, I have a problem doing complex fractions these days. So yeah, that's my issue, not really yours. All right, this to me looks exactly like arctan because it looks like 1 over 1 plus something squared. That is arctan, and also we just did arcsine, so I'm in a inverse trig frame of mind. So if that's the case, then it's 1 over 1 plus u squared, which would make u x over 6, which means that 6 du is equal to dx. All right, so now we need to change the bounds. So if x is 6, then u is going to be, if x is 12, then u is 12 over 6, which is 2. And if x is 6, then u is 6 over 6, which is 1. So we can completely rewrite our integral as from 1 to 2, 6 over 1 plus u squared du, or 6 integral from 1 to 2 of 1 over 1 plus u squared. All right, this is a perfect arctan, so we'll get 6 arctan of u, and from 1 to 2, apply the fundamental theorem. That gives us 6 quantity arctan of 2 minus arctan of 1. So arctan of 1 is a value that we should have memorized. The arctan of 1 is pi over 4 because the tangent of pi over 4 is 1. So as kind of a final step here, I'm going to do 6 arctan of pi over 4. All right, that's another good one. Let's look at the next one. We want to evaluate the integral from 2 to 8 of x squared plus 3x plus 12 all over x minus 1. So there's two very algebraic skills that you need to have going into the Calc AB exam, and you definitely need them for the BC exam as well. These skills are long division or polynomial division, and also completing the square. So on this one, it looks like we're going to have to do long division because the degree of the numerator is greater than or equal to the denominator. Anytime that happens, long division is the way to go. So I'm actually just going to do synthetic division on this thing because synthetic division is faster. So here it goes. I have a video where you can watch me go through all of how to do that, but you should definitely know synthetic division. All right, so that means that our integral is equivalent to integral from 2 to 8 of x plus 4 and then plus 16 over x minus 1. So we're going to reverse the power rule, and then we have 16 over x minus 1. That's a natural log. So let's do that. 1 half x squared plus 4x, and then we'll get 16 natural log absolute value of x minus 1. Fundamental theorem, so from 2 to 8. And just plug in. When you plug in 8, you get 32 plus 16 natural log of 7. When you plug in 2, you get 2 plus 8 plus 16 natural log of 1. But the natural log of 1 is 0, so that part's actually gone. So we get 32 plus 32 minus 10. So that's 64 minus 10 is 54. And then we have a 16 natural log of 7 left over. Well, not left over, additionally. Okay, so that's that question. And let's take a look at the last problem. These are all very straightforward, right? These are just doing problems. There's no real thinking involved. Evaluate the integral from Evaluate the integral of 1 over x squared plus 20x plus 101 dx. All right. You might initially think u substitution. Try to let u equal the denominator, but you do not have a 2x plus 20 in the numerator, so that's not going to work. But now you have a quadratic in the denominator. This is probably arctan, so we need to complete the square. So I'm going to rewrite, do x squared plus 20x. Then you want to take the coefficient of x, which is 20, divide it by 2 to get 10. Square that, 100, add it and subtract it. So we'll do plus 100 minus 100. And then there's still a plus 101 dx. The first three things should be your perfect square. So we have the integral quantity x plus 10 squared, and then negative 100 plus 101 is just 1. So we're there. This is a perfect arctan because if u is x plus 10, then du is just dx. So our answer here is going to be the inverse tangent of x plus 10 plus c. And that's actually the entire problem set. So I hope this was helpful, and good luck.